Dear math lovers, welcome to yet another problem of our channel. This time with our let's call it Math Mobile. We have traveled to Denmark for a problem from the Denmark Math Olympiad of 2017, or the Mohre competition as they call it. This is the first problem, so of course it is quite an easy problem, but however it is worth taking a look. The problem states: a system of equations in the set of real numbers is written on a piece of paper, but unfortunately two of the symbols are a little blurred. However, it is known that the system has at least one solution, and that each of the two question marks stands for either plus or minus. What are the two symbols marked as question mark? Yes, the system of equation is x squared question mark z squared is equal to minus 8, and epsilon squared question mark z squared is equal to 7. Please take the time to pause the video and write down a solution if you have any solution for this problem. If not, let's go through one step by step together. As always, we have hidden the solution, and we start by making some simple reasonings. So we have this system of equations, and we want to understand what the question mark stands for in this system of equations. Now, we start by making some reasonings on the first equation of the system. If the question mark is equal to plus, we would have that the sum of two squares, which are x squared and z squared, would be equal to minus 8, which is impossible. So we say that clearly the first sign of the equation would be the question mark is equal to a minus. So the new system would look like this, that x squared minus z squared is equal to minus 8, and epsilon squared question mark z squared is equal to 7. Or we take z squared on the other side of this first equation of the system, and we will have that x squared is equal to z squared minus 8. Now, from the first equation, we have that x squared is equal to z squared minus 8, or that x squared plus 8 is equal to z squared. Now we make the substitution of this expression in the second equation of the system, and we will have that epsilon squared question mark z squared is equal to 7. We substitute z squared equal to x squared plus 8, and we will have that epsilon squared question mark x squared plus 8 is equal to 7. If we suppose that the question mark over here is equal to a plus, we would have that epsilon squared plus x squared plus 8 is equal to 7, or that epsilon squared plus x squared is equal to minus 1. But this would be impossible because again, let's say the sum of two perfect squares of two squares cannot be equal to a negative number in the set of real numbers. So even in this case, we deduct that the question mark cannot be equal to plus, but it would be a minus. So the system of equations is now equal to x squared minus z squared is equal to minus 8, and epsilon squared minus z squared is equal to 7. So we now should prove, let's say to be in order and to be okay with the request of the problem, we should prove that this system has at least one solution as the problem statement requires. Now, by multiplying the second equation with minus 1 and by summing both equations of the system, we will have that the minus z squared and the plus z squared will simplify, and we will have that x squared minus x squared is equal to minus 8 minus 7 is equal to minus 15, or that epsilon squared minus x squared is equal to 15, or that epsilon plus x times epsilon minus x is equal to 15. We call this the equation number 1. Now we will leave it to the viewer of this problem to confirm that the equation number 1 has at least one solution with x and epsilon from the set of real numbers. A little help would be the fact that we can divide, let's say, given that on the left hand side there are two factors, epsilon plus x and epsilon minus x, we can divide 15 also in two factors on the right hand side. So by let's say by determining that both question marks are equal to a minus and that the given system of equations has at least one solution in the set of real numbers, this concludes the proof of this problem. If you like this problem, please don't forget to like, comment and subscribe to our channel, and see you on our next videos. Up to then, goodbye.